Okay, now for chapter 5, the title will be Work, Energy and Power. You guys dah try baca belum this chapter? Guys?
Sir, saya nak ambil nota je.
Okay, tak apa. Okay, one more thing. This next Friday, we will have UPS at 5 PM. UPS is very important sebab dia makan besar. It's about berapa persen? Yeah. 10% lah. It's about 10%. Which is pretty much can decided whether you get A or B or not an A lah. Okay, yang lain dah ready belum? Senyap je.
Dah, sir.
Tarvin okay?
Okay.
Hi Tarvin. Okay, so today we have 3 subtopics for today: work, energy, and power. So we're gonna discuss all of those. Work, energy, and power. Okay, so work ni, it comes from a definition of work equals to F dot S. Okay, so F dot S actually means F dot product with S. So dot product, as you guys know, will become Fs cos theta. It is actually, dot product means product of X component for F multiplied with S. So in terms of drawing vector, we can try to draw it like this. Let's say my F is in that direction and my S is in this direction. So dot product is actually X component, which is this one, Fx, which is equals to F cos theta. If this one is your theta. So the theta is actually angle between F and S, and your work now become Fs cos theta. So I'm going to write it in a new slide over here. So most of the time you guys will be dealing with Fs cos theta. So the theta here is basically the angle between F and S. Okay, S here is the displacement. Okay, the SI unit will be in meter. It's a vector, so the direction is important for S. And F is a force, so again it's a vector as well, with a unit SI of N. Okay, dot product, it will produce a scalar quantity. So the work here is basically a scalar. Okay, the unit is basically joule. Okay, if you look at the unit for work, which is joule, and energy, which is also the same, do you think that it is relatable? Adakah kamu rasa work dengan energy tu benda sama? Is it the same? Kamu rasa? Apa opinion kamu?
No.
No? Yeah, okay, it's okay. Lain?
No.
Shazwina? No? Okay. In terms of unit, yes, it is the same. In terms of quantity, it might represent a slightly different things, but it is basically almost the same thing. Dia macam lain, dia macam sama. Anyway, nanti kita bincangkan lebih lanjut. Then you can see lah. And what else? So it's a scalar. So unit is joule. Okay. And then it depends. So obviously, this work, it depends on, it is directly proportional to the F. Okay. And it also directly proportional to the S. So it means that the bigger, the further you do your work, then you will have a larger work. Okay. So you have to consume more work lah. So example, for F, let's say if you want to lift a heavy object or you want to push a heavy object, obviously you have to push with a high F. So that means you have to use lots of work. Work in terms of energy is basically the same thing. It's energy as well. And then this one for displacement. So let's say if you have let's say if you try to push a wall, okay, and the wall is not moving, so basically the S will remain zero lah. So if the S is zero, your work is basically zero, even though after a while you got tired pushing a wall, but because the wall is not moving, that one is considered work equals to zero in terms of work done on the system. Yeah, so later on you will see about system and all, ada macam saya akan sebut lah pasal system, on the system, by the system. So basically you are dealing about a closed system. So object tu kalau selagi tak ada external force, dia akan remain as it is. So itu konsep dia. Nanti kita akan belajar lebih lanjut, so don't worry. So cos theta, what is the maximum value for cos theta? Anyone can tell me? What is the maximum value of cos theta?
90.
90. Okay. Maybe I have to rephrase my question. Kalau kamu perasan, cos theta ni kita ada graph kan? This is a cross graph. So the values of cos theta actually varies between 1 and -1. The value daripada sini, turun bawah, ni atas, turun bawah, ni atas. So it's always varies lah. So again, back to my question. So cos theta will be maximum when it is equals to berapa?
1.
1. Okay, very good. Okay. So at what angle? So tadi I think you answer at specific angle lah. So when it is equals to 1, cos theta tu berapa? Theta tu berapa bila dia equals to 1?
Kosong.
Yes, correct. Lagi satu? Bila kosong lah. So when
Bila
cos 0, sorry?
360.
360, correct. Okay. So cos theta is equals to, when theta is equals to 0, so cos phi equals to 1 lah. Cos theta equals to 1. So the work will be maximum. Okay. So when theta is equals to 0, okay, theta ni, if you go back to the definition here, it is actually an angle between force and displacement. Okay, so it means that if this one is 0, F and S is actually in the same direction. You guys agree with this? Boleh bayangkan tak? You guys okay?
Maksudnya dia kalau ke kanan je.
Yeah, maksudnya F dengan S tu sama direction. Maksudnya F tu ke kanan, S tu ke kanan. So same direction, it means that theta is equals to 0. So that F is actually contribute the largest work lah. I mean, it will be a maximum work done on the system if it is in the same direction compared to not lah. Okay, when is that cos phi equals to 0? Masa bila dia jadi 0? Cos theta ni sama dengan 0.
90 dengan 270.
Okay, good. So when theta 90 ke? Yeah, 90. Okay. When theta is equals to 90 degrees, cos phi becomes 0. So that means work done equals to 0. Okay. So what does it mean that, okay, let's say if you have an object. Okay, katakanlah kamu dengan rakan-rakan tengah angkat meja. Okay, angkat a box lah. Okay, let's say you are pulling the box in this direction, S. Okay. and then you are basically in the middle here, and you are just simply apply a force directly upwards. So this is forced by U lah. Okay, and if you look at the angle between F and S over here, the theta is basically equals to berapa degree?
90.
90 degree, correct? So if the theta is equals to 90 degree, the work done by you on the system is actually equals to 0. So basically if you do it like this, you didn't contribute anything. Okay, even though kamu pernah angkat kan, tapi dia memang tak ada work done on the system, tak ada contribute any. Okay, so hopefully you guys can understand those kind of thing. Macam contoh tadi tu, kalau kamu ada wall, if you apply a force in this direction, but since the S is equals to 0, then again the work done is equals to 0. Okay, and then what is the example when theta is equals to 180? Can somebody tell me? What if theta is equals to 180?
-1.
Yes. So I'm going to bring this one a little bit further up. Okay, when theta is equals to 180, then you have cos theta equals to -1, so you have a negative work. Okay, so example there, if you have a box like this, the box is moving in this direction, and maybe you have a force in that direction. Okay, maybe it's a kinetic friction, maybe, yeah. So if you have a force in that direction, then the theta will be 180. So the work done by kinetic friction is actually negative. Okay, so it means that energy is going out from the system. So right over here, what does it mean? Positive work, negative work, zero work. So this one is basically no work done on the system. Okay, this one, work done energy out of the system, work done by the system, energy out. Okay, this one, work done on the system, energy in. So now you can see that work and energy is actually relatable. Okay, contoh if I want to okay, let's say I have a box over there, and this is my table. Okay, so I want to lift the box and I want to put it over here. So I have the S, which is my height of the table lah. Okay, so basically I have to apply some work. Okay, so you have, if I want to consider this is my F, so the F would be a positive work done on the system, so energy being put into the system. So initially, let's say this is my height equals to 0. Let's say this is when height equals to 0. This is height when it's equals to 2 meter. Contoh besar, tinggi 0.5 meter. So it means that initially there's no potential. Okay, U equals to 0. And then over here you have a potential. U is not equals to 0. So the potential that has been done on this object is basically your work done. Faham tak maksud saya?
Seulang semula boleh?
Okay, maksudnya kan, kalau objek ni dekat bawah, tak ada work done on this object, the box will remains at its own place lah, dia akan remains kat situ. Tak ada potential energy sebab dia dekat base kan, so dia tak ada bergerak lah. But then if I want to put this box into on the table, I have to apply some work untuk angkat dia. So the force that I use to pull the box into the table is basically the work done on the system. Basically, I applied some work into the system, and then energy tu dia tak hilang. Energy tu dia tukar jadi potential energy untuk the box. So maksudnya dekat sini saya ada explain saya mengenai conservation of energy dan juga work energy theorem, which is what you're going to learn in the next subtopic. Okay, so kalau kamu tak faham sekarang, it's okay. This is just a concept lah. So saya just introduce work ni dia boleh jadi positif, negatif and zero. It depends on the situation. Kalau dia positif, work done on the system. Negative, work done by the system. Energy transfer out, energy transfer in. Kalau yang ni dia tak ada work done. Okay. And then the energy yang in dengan out tu dia akan transform bentuk dia. Work tu transform jadi bentuk, maybe jadi kinetic energy, maybe jadi potential energy, maybe jadi elastic potential energy. Do you guys get the idea or tak? Macam at least sikit-sikit lah, sama-sama. Boleh dapat tak idea dia?
Boleh, sir.
Boleh Okay, good. So okay, sama-sama sebab memang tak buat tutorial lagi, and then maybe this is the first time kamu dengar. Okay, now the important bits about how to use the formula. So work here is equals to F S cos theta. Semua orang tahu this. Semua orang want to use. But bila exam, ramai confused sebab work for question for work ni, sebab dia tak confused work tu work apa. Okay, the thing about work ni, kalau soalan dia nak tanya work on the system, we call that one as work net. Okay, maybe pensyarah ni jarang pakai, tapi saya pakai work net. Your F here would be your F net. Okay, so kalau saya nak cari work done on the system, contohnya this is my system. Okay, let's say this box is travelling from point A to point B at the distance of S. Okay, I have a force in this direction and I have a friction in this direction. Okay, so ada dua force, ke kanan dan ke kiri, and then I also have the normal and the weight macam biasalah. Okay, so when you try to solve the work question, make sure you draw the free body diagram as well. Walaupun dia nampak macam tak pakai, you have to draw first. Then only you can see and understand. Okay, so this force is basically F external. I put that one as F1 lah. So untuk differentiate between F net dengan F. So kalau dikata nak F W net, you have to consider all. Okay, contohnya in this case, kamu punya box move in X punya component. So obviously you can ignore the Y component because that one would be theta equals to 90 degrees. Kalau theta equals to 90 degrees, basically tak ada work done. So N dengan W ni, for this situation, dia tak contribute to the work done on the system. Agree or disagree? N and W work is equals to 0. Okay, do you guys agree with this statement or not?
Agree.
Agree. Agree. Okay, sebab apa? Sebab theta dia equals to 90. Macam mana theta tu equals to 90? Because if you look over here, the N is directly upwards, perpendicularly upwards to the S. Okay, so it's 90 degrees. While weight is downwards and 90 degrees to the S. So apa? Theta ni mesti daripada S dengan W. S dengan force tu lah. So S is in that direction. Okay, so in terms of work done on the system or by the system, the one that contribute is actually your F1 dengan FK. FK. Okay, ada dua force yang contribute to the work done. So kalau saya nak cari work net, I have to use F net. And in this case, since S is in X component, so I can write this one F net untuk X component, and this will be X component as well lah. Okay. So far boleh ikut ke tak?
Boleh sir.
Boleh.
Yeah. Okay, now if I want to substitute my f net x, so summation of f net x actually equals to f1 minus fk for this situation. So here you can write my w net is equals to f1 minus fk multiply with sx multiply with cos theta. Okay, this one if the question asks you to find the total work done on the system, net work done on the system, work done on the system. Maksudnya dia tak cakap spesifik, dia due from the force ke friction ke, dia tak cakap. We assume dia tanya untuk keseluruhan. So bila dia tanya keseluruhan, you have to use F net X. Okay, please remember that. Okay, ramai student terlepas pandang yang ni lah. Okay, katakan soalan yang tanya work done by the force. So work done by external force, which is F1. So if the question asks you to find this one, you need to use F ni sebagai F1. Okay. Ya, kalau ditanya net, you have to use F net. If the question asks you to find F1, you have to use F1. Okay. In this case, theta dia sama dengan berapa? Berapa?
90.
Okay. Dia punya force F1 tu ke mana? Direction dia?
Kanan.
Ke kanan. Like this side. S dia direction ke mana?
Oh, ke kanan.
Kanan.
So theta dia sama dengan?
3.
Okay, good. Very good. So
Oh, okay.
if S and F in the same direction, it means that it moves in the same direction. I mean, the theta would be 0 lah. Okay, clear? Okay, good. Very good. Okay,
Yes,
now, alright. Work done by friction. So you have to use work done by the friction equals to Fk as cos theta. I think by now you can see the trend lah. It depends on the question, whether the question asks you specifically to find work done by a certain force. That means you have to use the force tu sebagai F yang certain force tu lah. Kalau dia kata on the system, you use net. Okay. Kalau in this case, theta dia sama dengan berapa?
180.
180. Okay. Kalau cos 180 would be negative 1. So you will expect work done by the friction will be negative, which means that energy transfer out from the system, which is kind of true. Okay. Kadang-kadang kamu ada kinetic energy initially 100. So after a certain time, maybe the kinetic energy lose out to the friction, which is about 20 joule. Contohnya. So it kind of makes sense so far. Okay, katakanlah, let's say the question asks you to find the work done by gravity. Okay, force apa yang due to gravity?
Weight.
Weight. Okay, so we use the force of weight dekat apa tu, dekat slot force tu kita substitutekan dia sebagai source pula. Cos theta. Kita substitute sebagai weight instead of the lain. So weight ni force juga. Kan? So in this case theta dia sama dengan berapa? Tadi kita dah discuss lah. Saya tanya balik.
180.
Okay.
90.
Theta.
90 kan?
Yes. Okay, it's actually 90. So in this case theta sama dengan 0 degree. This one is theta sama dengan 180 degrees. And this one is theta equals to 90 degrees. Okay, kenapa 90 degrees? Because the weight is pointing downwards and the S is pointing to the right. So I know already before we start calculating the NW, and NW does not contribute to the in this case lah soalan yang macam ni je. Kalau dia slanted, dia lain lah. It does not contribute to the work done on the system. So to test that one, you can try to substitute the formula and you will get this one equals to 0 as well because theta is equals to 90 degrees. So yeah. The same thing happens for, the same thing will happen when you use normal force lah. So N is equals to cos 90 as well, so that one becomes 0 as well. Okay, so far any question? Okay, senyap tu saya assume tak ada. The important bits here is that this is the main formula. Go back up here. Oops. Tak pening. Okay, so this is the main formula. Okay, and this one thing that you need to be particular about is that soalan tu tanya work untuk apa. You have to read the question properly. Dia memang akan sebut. Kalau dia tak sebut, kita assume dia nak cari work on of the system. So if work for the system, this is my work net. This is my F net. Okay. Anything else you have to use lah. Work by the gravity, W. Weight. This one is W. Weight. Kalau work done by the normal, so you change this one to normal. Work done by the external force, so F external. So this is the key thing. Okay. And then jangan confuse pasal theta tu. Sebab tu you really have to draw the free body diagram to see in which direction is your F and your S. Okay. So if there's no question, we're moving on to the next subtopic, which is about energy. Okay, energy ada dua konsep yang penting. Okay, so this is your 5.1. This is 5.2. And this is 5.3. Okay, for energy, you have key important bits lah. The first thing is that the types of energy that you'll be dealing in this chapter are the three types. One is gravitational potential. Okay. Normally we use this one as U equals to mgh. Okay, sometimes we might put this one as ug lah. Sometimes, sebab nak separatekan dia. Okay, another energy is actually your kinetic energy. Can somebody tell me what is the formula for kinetic energy?
1/2 mv square.
Okay, good. It will be half mv squared. Okay, and then the last one that maybe you guys not too familiar with is elastic potential energy. Which is what we represent with US. Okay, US ni memang kena tulis. Kalau UG tadi, kalau tak tulis, biasanya kita assume that one is UG lah. Tapi kalau US, you have to write. Okay. This one will be half kx square. Okay, daripada mana datang half kx square tu? It actually comes from the Hooke's law. Okay, I'm not gonna go to derivation. You can try to see at your notes. Either tunjuk derivation dia, and then you can refer lah. But most importantly, you need to know how to use these three formula. Okay, so M is mass, V is velocity, H is height, and X is actually elongation. X here is basically elongation and compression of a spring. Okay, kalau spring lah, kalau rubber sama juga, elongation and dia punya compression. The K here represent the coefficient. So biasanya itu diberi jugalah. Okay, these three energy is basically a scalar quantity. Okay, and the unit will be in joule. Okay, as long as you use everything in SI unit. So mgh, M lah biasa yang ditukar. M tu biasa kadang-kadang dikasih dalam gram. So that one you have to change to kilogram. Then only you can substitute inside the formula and you can try to solve. Okay, ada soalan about the three types of energy?
No, sir.
No, sir.
Okay, good. Okay, one important thing here is that you can see that two types of energy is potential. One types of energy is kinetic. So the kinetic actually depends on the speed of the object. So this one, kinetic lah, how fast it moves will contribute to the kinetic energy. Potential means it depends on the position or shape of an object. So in this case, kalau dia dekat certain height, you have a different potential. Different height, you have another potential. Kalau yang ni, it depends on the form of the body. So kalau dia lagi stretch, X dia lagi besar, US dia lagi besar. Okay. Itu contohnya. Okay, let's try to look at the key thing here is conservation of energy. So in chapter 3, you learn about conservation of momentum, but in this chapter, you will learn about conservation of energy. So conservation of energy means energy is conserved throughout the for a closed system. Energy will always be conserved lah daripada awal situation sampai ke akhir situation. Contohnya, let's say if I have a ball roll from a hill. This is a ball. It's being rolled from the hill. So initially, it is at rest. U is equals to 0. Okay. And due to its height, okay, dia ada height. Let's say this is my reference point. H equals to 0. And remember, the height is actually it's your reference point. Kalau kamu buat conservation of energy, which is summation of E initial equals to summation of E final, basically you can decide where you want to put your H equals to 0. Kamu yang letak sendiri kat mana. Biasanya minimum position itulah yang kamu assume dia punya high equals to 0. Supaya dia boleh hilangkan U tu, potential energy. Anyway, so this one tu and jatuh dekat sini. So you have point B, point C and point D. Okay, so bila dia pergi ke point B, you think that the potential energy is increase or decrease daripada A dia pergi ke B?
Chris?
At point B, I think I have to turn out switch on to Wi-Fi because internet saya problem. Okay, dekat point B tu, do you think that the potential decrease or increase when you compare with point A daripada initial position tu? So objek ni jatuh bawah lah, kan dia turun bawah. So do you think that the potential energy decrease or increase? Guys,
Decrease.
potential energy decrease because kenapa?
Sebab high dia.
Yes, sebab high dia decrease. So you can see at the formula, you can look back at the formula of MGH here. The UG depends on the height. So the lower the high, the lower the potential. So dia berkurang. So let's say dekat B, katakanlah kamu punya UG equals to 8 joule. Okay. So initially kamu ada 10 joule. And then they decrease kepada 8 joule. My question is, mana pergi lagi 2 joule? Okay, asal dia 10 joule. Lepas tu at point B dia decrease kepada 8 joule. So where do you think the 2 joule go?
Kinetic.
Yeah, it becomes a kinetic energy. So the another 2 joule is actually transformed into kinetic energy. So this is the concept of conservation of energy. That means the total energy will always remain the same, constant lah. So this one total is 10 joule, sama macam yang asal tu. Cuma the shape of the energy is changing. And the form of the energy is changing lah. Daripada potential jadi kinetic potential. Okay, at C, do you think that the potential will continue to decrease ataupun dia naik balik dekat point C?
Decrease.
It will continue to decrease, right? Let's say now they decrease kepada 4 joule. So the kinetic energy becomes
6.
6 joule. Okay. And how about at D?
UG potential 0.
UG is equals to 0 because we put that one when the height is equals to 0. And the kinetic now becomes 10 joule. So there's no energy loss and all the energy is being transformed to one form into another form. Okay, so clear tak?
Yes, sir.
Okay, kamu dengar suara saya macam mana? Okay. Okay.
Suara yes, sir.
Okay, sir.
Sebab saya punya wifi tiba-tiba drop. Dan dia tak ada internet terus. Tapi saya punya iPad saya ada lah. Saya tak nampak kamu je lah. Itu je lah. Okay, anyway. This one is for potential and kinetic. So I think you guys are familiar with this. Common example maybe roller coaster or something like that. Okay, what if I have a spring? Okay, let's say this is my object attached to a spring. Okay, so initially when this object is at equilibrium, so that means your x is equals to 0. Yeah? So when x equals to 0, what can you say about my US? Elastic potential. Okay, if you go back to the equation here, you can see that US is depends on half kx square. Kalau dekat equilibrium tadi saya cakap x equals to berapa?
0.
0. So kalau see here it becomes 0, the whole term over here becomes 0. So US is equals to 0. So if this object is at equilibrium, maksudnya dia tak bergerak, dia memang daripada asal, dia memang kat situ. So that means there's no potential, elastic potential in the spring. Okay. So obviously kalau saya biar, dia akan keep on being 0 lah. So sebab saya nak buat cerita, takkan saya nak biar dia kat situ kan. So let's say saya compress it a little bit. I compress the spring. Now your spring is no longer at x equals to 0. In fact, maybe dekat sini x equals to negative 2 cm. Contohnya lah. They ask you to calculate, you have to change the cm to meter first. Okay, and then katakanlah your potential energy now, because it's half kf square, so negative positive, you still have a positive energy over there. Katakanlah sini adalah 10 joule. Okay. As the object being released, katakanlah dia tengah release. Let's say now my object is slightly over here. Dia dah bergerak. Maybe when x equals to 1. So what types of energy do you think you have? At B, contohnya, energy apa yang kamu ada?
Kinetic ke?
Kinetic betul? US ada tak?
Ya.
Ada.
Sebab apa? Sebab dia masih tak habis decompress. Dia tak pergi balik ke tempat asal lagi. Dia belum sampai ke sini. So you still have the potential energy because the spring is still being compressed. So katakanlah potential energy now is 4 joule. So your kinetic energy will be berapa joule?
6.
6 joule. Okay, good. Okay. Katakan pula dekat point C. So basically after that, bila dia sampai maksimum ni, this one object to detach, tercabut. Do you still have the elastic potential energy? Ada lagi tak?
Tak.
Sebab apa?
Dia sebab dia dah dekat tempat ni.
Dah tercabut.
Okay. Dia
Tak bergantung pada
okay, betul. And jawapan paling tepat sebenarnya bila dekat sini x dia dah equals to 0. So bila dia dah patah balik ke tempat asal, which is at equilibrium, x equals to 0, so your US is equals to 0. And the whole energy of 10 joule, it becomes kinetic energy. Okay. Understand or not?
Understand, sir.
So conservation of energy. Okay, the things about conservation of energy, sometimes you can solve using chapter 2 punya equation. Boleh, ada certain boleh. So dalam soalan kadang-kadang dia kata using the conservation of energy, try to solve the problem. So dia cakap, so kalau dia cakap memang kamu kena pakai. Kalau dia tak cakap, it's up to you nak pakai yang mana satu. Chapter apa pun tak kisahlah, janji dapat jawapan. So kat sini you have summation of EI equals to summation of E final. This is something that we call concept lah. So bila dia konsep, kalau kamu tulis, kamu dapat markah. Kalau dia ada markah. So I strongly suggest you to write down the formula EI2 equals to EF2. Very important. And then another thing is about the types of energy. So kalau ada 3 energy je, so my suggestion is you always write down all the energy so that you didn't miss anything. Okay, so this one you put lah. This one is initial, final. Okay, contoh kalau tadi tu, yang case yang spring tu, initial kamu ada USI saja, kinetic tak ada, kan? So you can cancel out this one. So potential of the spring equals to final, you only have the kinetic, so you can cancel out the others as well. So my suggestion is tulis je semua and then you cancel out mana yang tak ada. For me, that one is better so that you didn't miss on anything. But then if you guys comfortable with doing it straight away, USI sama dengan K, then you should be okay. Tak ada masalah pun, tak ada issue. Okay, another part is about work energy theorem. So like itu before, work and energy ni sangat related, and in fact dia ada relation lah. Work sama dengan delta K, okay, where delta K indicates the change in kinetic energy, which is K final minus K initial. Okay, since we are talking about the work done in work energy theorem, this one will be work net. Dia memang tak ada work lain. So if you want to use this formula, make sure you use work net equals to change in kinetic energy. This is very important. So sometimes sudah masuk kat sini sebagai weight F ataupun weight gravity, weight of the friction. So dia salah lah. Dia memang fokus on work net, baru kamu pakai equation ni. This equation. Okay. And then sometimes conservation of energy you can include with the loss of energy due to work. Kadang-kadang ada soalan macam tu kan. So you can write down that EI is equals to E final. Okay. So initially katakan you ada kinetic tambah dengan UG. So the final will be KF tambah UG F tambah dengan work done on the system. Kalau ada friction, dia keluarlah negatif, kamu akan dapat negative work. Contohnya saya letak di F. Contoh je. Again, nanti kalau kamu dah jumpa soalan, maybe kamu nampak dengan lebih clear kot saya cakap apa ni. Okay, ada soalan so far?
No, sir.
If there's no question, we're moving on to the last subtopic, which is subtopic 5.3 about power. Okay, power is simple je. You have 2 types of power. One is average power, call that one as PAVE, and then you have P instantaneous. Okay, as long as it is understandable and the instantaneous average, it should be okay. Kamu nak pakai simbol apa pun okay. Okay. P average ni you have to consider the whole journey. And so if you want to consider the whole journey, you have to consider the whole work done on the system throughout the time. Okay, the work tu biasanya adalah work net, unless they specifically said work, so the power done by the force F1. Itu kalau dicakap, then you have to calculate work untuk F1 lah, nanti dengan bahagikan dengan delta T. Kalau instantaneous pula, dia ada V, F dot V. So it depends on the velocity to determine whether the power used is high or not. Okay, so basically this formula kamu boleh hafal lah. And normally they will ask you in the last part of the question. Macam contohnya AB dia tanya pasal work dengan energy, dan yang C tu dia kata okay, calculate the power done for the object A contohnya. The unit for power will be watt. Okay, and then we use the symbol W je lah biasanya. And since this one is dot product, this one is scalar, so the whole thing is scalar for power. Okay, ada soalan?
Betul.
Okay, kalau tak ada soalan, now saya nak kamu cuba buat soalan tutorial. I think you guys can try to do the rest of the question. Cuba buat. Kita ada 1 jam lagi. Kalau ada soalan, boleh tanya saya. Okay? Okay tak?
sir.
Boleh tak?
Okay, sir.
Okay, jangan tidur pula. Cuba buat tutorial chapter 5. Okay, I think we stop here now. Tomorrow kita discuss on the tutorial. Please do it in advance so that kamu tak tertinggal lah. Alright, there's no question. I think we can stop now. Okay, thank you.